Good morning, dear students. Good morning, all of you. This is a video of class 11, and in this video, we are going to discuss about the topic, and that one is alkenes. As you all know, that this one is a type of hydrocarbon which actually contains double bond in between carbon and carbon, and the general formula of that alkene is CnH2n. Okay, na? So we will see the alkenes here. The alkenes are unsaturated hydrocarbons. As you can see here, it is written. The alkenes are unsaturated hydrocarbons containing carbon-carbon double bonds in their molecules. They have the general formula CnH2n. CnH2n is the general formula. The simplest member of alkenes, the very first member, N should not start from 1, it should start from 2. That's why C2H4 is there. And alkenes are also called as olefins. We have previously discussed about that one. That means oils forming. Because of the larger member of this series, such as ethylene, propylene, it reacts with chlorine to form oily products. That's why it is called as a olefins. Now, the next thing you can find here, we will actually discuss also about the isomerism in alkenes, and there are different types of isomerism. Alkenes can also perform here. Alkenes would be there. Alkenes, Alkenes, alkenes. That structural isomerism and geometrical isomerism are the two types which alkene can perform. Structural isomerism, chain isomerism, position isomerism, and geometrical isomerism. In that one, we will study about the cis isomers and trans isomers. Okay, so we will see. Please wait. So here we will talk about the isomerism, and isomerism in alkenes we will talk. And you know that the isomerism in alkenes can be the structural isomerism and the geometrical isomerism. So very first one that we will go and talk about the structural isomerism. Okay, so structural isomerism, if we will talk, it is visible. Okay, structural isomerism we will talk, and in this structural isomerism there are various types of structural isomerism. Chain isomer, okay, then position isomer would be there. So that isomer, structural isomers, ethane, propane, do not have, only simply we can write. If I am going to write the ethene, then CH2 double bond CH2, okay, propene CH3 single bond CH3 single bond CH double bond CH2, propene is there. But if you write butene, so it will have some chain isomers also and position isomerism also. So here I will go to take one example, and that one would be of butene. So here I have written CH2 double bond CH single bond CH2, and then after at terminal position we can write the CH3. Okay, na, CH3. So this one is the butene, and this butene is at the first position, very first position. A double bond is there, so one, you can write but 1 in, you can also write like this one. Okay, na, but 1 in. But here you can see that the terminal carbon I can also change, and I can also change this double bond from here, from the very first position to the second position. So second isomers would be there, CH2 single bond, CH double bond, CH and CH3. So this one you can see 1 and 2. Here the position of double bond is actually shifting, but I can also write this one as I can also write this CS3 position, CS3 at this or at this position. So what it will give you? It will give you a new structure. It will give you a new structure, please. Okay, so it will give you a new structure if I will take this CS3 from here, and if I will adjust in between here at these positions. So CH2 double bond CH and CH3 will come here. CH3 CH2 will be at terminal position, so CH3. So this is one of the more isomers you will get from in the structural isomerism. So what is this one? 2 methyl prop 1 in. This one is the structural. Okay now, so this one you have got in the butene. There are 3 types of structure you have got. One, if there would be a structure 1 and 3, this structure 1 and 3, and 2 and 3, 2 and 3, both are having the different example, and both are the example of chain isomers and the position isomers. Okay, now we will discuss about the geometrical isomerism. Please wait. Geometrical isomerism, actually we are talking about when the carbon and carbon is actually containing double bond, and from each carbon there would be some different or similar groups would be there. How? Geometrical isomerism, GI. Okay, if I am going to write about the GI, then you can see here C double bond C, here X, here Y. You can see from the same carbon, if you are seeing XY is there, XY is there here, and XY is here in the same side, X and X, if the same side is there, Y and Y the same side, bottom, and below you can see YY is on the same side, XX is on the top same side, then this structure is known as cis isomers. Cis isomers. Okay, instead of this X I can take CS3, so this one would be CS3, this one also would be a CS3. Okay now, this Y should be H and H. If there would be same side, then this would be the cis isomers. But if there would be the different side, suppose if I will write C double bond C, hydrogen, CH3, and then hydrogen, then you can see CH3, one is going upside, one is going downside, hydrogen one is going upside and one is going downside. So this one is known as trans isomers, and this one is trans-but-2-ene. Trans-but-2-ene because 1, 2, 3, 4. Okay now, as it is trans structure, so I have added trans first of all. So trans, this one is trans. Okay, 4 carbon is there. So but I can write trans dash but 2 at the second position, double bond is there. So 2 and the for double bond we will use in. So trans but 2 in we have used in this case. So geometrical isomerism, from that geometrical isomerism we can also calculate the dipole moment. Okay, how will you calculate? How you have done the polarity, bond polarity, the negative element, the electronegative, the most electronegative attract the electron towards itself. So dipole moment direction would be towards that self, okay na, that sides, okay, and we can able to calculate the dipole moment from that. Okay, so here we will discuss that one, but first of all, geometrical isomerism and structural isomerism you have to do in this video. Okay, and we will solve the dipole moment in the next video. Okay, thank you.